Hi, everyone. So my talk will not include microscopes, mostly data management. And so what we've done at Microscopy Australia. And I subtitled that as a mosaic and a journey. The journey is pretty obvious for data management at Microscopy Australia, but mosaic because, as Lisa said this morning, we are an open access network of facilities, and we have 9 university-based facilities. That means 9 institutional environments, and all the facilities are different, and they are all on, each university has its own data governance, and each facility is on its own journey in terms of data management and fair data. So I focus my talk on the ACCS project, the Australian Characterisation Commons at Scale project, which ran from mid-2020 to June, July of this year. And the ACCS project actually, we did a lot in data management in general. That was useful for all of the microscopy facilities across the country. And since then, Microscopy Australia has built more things upon it. So very briefly, ACCS was a project that ran for 2.5 years, and it had many partners, 10 universities and 3 increased capabilities, so research infrastructure organizations, Microscopy Australia, the Australian National Imaging Facility, NIF, and ANSTO, and actually there are more, they were also POSI. That's wrong, no? I recycled the slides from another source. So the ACCS project had something like 7 work packages. There were 3 work packages focused on techniques or communities, 1 on microscopy, actually electron microscopy, 1 on imaging, and 1 on X-ray and neutron scattering. I will only talk about the one that Microscopy was involved in, and was about big data, EM, and correlative microscopy from instrument to publication. So the premise of this work package was that basically now, with the new generation of microscopes, there are new challenges for the facilities. The volumes of data produced keep increasing, and the acquisition speed keeps increasing too. And that creates new data processing requirements, because some of the data sets generated can be massive. Some facilities can generate maybe a terabyte of data in a day. So that definitely puts different pressures on those facilities, how you manage this flow of data, how you sort what is rubbish and what is meaningful, for example, and how you can also transfer this data in a timely way. And from also another data management perspective, you will all be aware, there's a lack of standardization overall in data formats and also in metadata, even though there are initiatives. It's very heterogeneous, and some communities so far, for example, are more organized than others when it comes to standardization. So the aim of this work package was very ambitious. It was to develop platforms, tools, guidelines, and standards, and to deploy or adopt the solutions at least at 1 institution that was partner of the ACCS, and ideally at more than 1. So that's briefly the team that worked in this work package. So you can see it was quite distributed. It was 5 institutions, and I will present briefly some of the work by Josh, Huang, and myself. So that's the 4 basically areas in which the work package worked. There's a link to the Microscopy Australia website when you can find the list of all of the outcomes of this work package. In particular, you can find the DOIs of all of the reports out of this work package. And all of the reports are not written in IT jargon. It's supposed to be useful for the facilities too. There's a bit of jargon for the IT or e-research staff that assist facilities, but it's mainly understandable for facilities. One aspect that was very interesting out of this work package was something that Josh Silver at University of Wollongong worked on. And basically it was how you can change some settings in the workflows at your facilities and achieve big outcomes. So many workflows at facilities actually were set up quite a while, and sometimes you have a lot of legacy traditional tools and settings that were maybe set up 5 years, 10 years, 20 years ago, and they've never been updated. And if you optimize those settings or those tools or rewrite some scripts, you can actually have big achievements without investing in new hardware. Like, for example, at University of Wollongong, so Josh went through all of the workflows they had in the facilities and all of the settings and the tools and everything. Some of the settings in the data transfer had been written in a way that was very safe to make sure there was no data loss compared to how much data basically the instrument was pumping out. But also some were very old. Since then, internet has been a bit faster. And through all of those steps of optimization and rewriting some scripts at the University of Wollongong at the microscopy facility, they've been able to optimize storage of data, but also achieve near real-time data transfer and near real-time data visualization and data assessment. That's a massive outcome because I would say all they had to do was basically have Josh, which is cheaper in general than the big, expensive, shiny hardware. And now they've kept Josh because they saw like there's a huge advantage to have an IT person within your facility. So IT or e-research. So if in Europe you will call that e-science, and if you're, for example, in North America, you'll call that cyber infrastructure. That's the same. And so there's a real, in terms of lesson learned, having an IT or e-science support makes a massive difference for your facility. Another thing that was a major outcome of this work package was the development of Peachy, a data management software at the University of Queensland. So the objective was to have Peachy as a way to ingest metadata alongside the data and to synchronize that with a data management system used by the facility. And it had also to enable fair data. So Peachy had to be able to ingest metadata, to collect metadata and ingest it, and also be able to evolve over time. For example, if the facility wanted to collect more metadata. And it had to be simple to use. It's important. So very briefly, that's a kind of diagram about how Peachy works. I think what's very important is that, so the base, the data management system used is Clouder, which is a framework, open source framework. And then Peachy, so like customization and interface on top of Clouder that collects metadata, for example, from the booking system at the facility, from the instrument, and ingest all of that in a single place in Clouder. And you can see you can have things like from booking system, you can have the project ID or the project name. You can have the user ID. So maybe ideally you could have the ORCID to identify users. You can also get the booking. So for example, when data was created or when the project was created. So it's very powerful and it's very flexible too. Now, I will present also two things that I worked on myself in this work package. It's metadata collection and data retention and disposal. Metadata collection is essential to fair data, and there is no point in collecting metadata manually. So the question is, how can a facility collect metadata effectively, automatically, and systematically? So for that, I've interviewed 4 other facilities and could identify challenge and barriers. And what was very interesting there is, in general, facilities are all on board when it comes to fair data, but they just can't collect metadata because they have an institutional environment where you have siloed information system, where you have booking system that can't interoperate with your data management system. So they just can't collect metadata. So I've developed guidelines for that will roll out across Microscopy Australia. And also worked on practices in research data retention and disposal. And for that, I did a survey of the practices at the facilities and developed guidelines too. And beyond ACCS, so some facilities have expressed interest in implementing Peachy or at least testing Peachy at their facility. So that would definitely enhance metadata collection across Microscopy Australia. And I think something that's been great for us is those outcomes have come at a very right time at the intersection of several initiatives or priorities for universities. For example, several universities in Australia are working on this business intelligence and what sort of data and how much data they have. Surprisingly, many universities in Australia, and also I know Chicago Uni and MIT are facing this basic challenge that they don't know how much data they have, they don't know what sort of data it is, and sometimes they don't even know the owners of those data sets. What do you do with that? So if you collect metadata, you can know what you have. So the institutional environment is very important here. And also in Australia, there's currently a national initiative on a strategy for persistent identifiers. And for that, that's essential also to metadata collection. And Microscopy Australia is focusing on how to identify instruments, organizations and facilities with a raw ID and a grant ID as a trial. And just very briefly, why PID for instrument? Well, of course, you can identify your instrument uniquely, but you can put so much and advance on so many aspects on metadata collection and fair data. For example, you can identify your facility with a raw ID. Lesson learned about that. If your facility wants a raw ID, who do you ask within your university or your organization? This question is still open. We still don't know. You can identify the funding and maybe then acknowledge the funding. And you can standardize vocabularies. For example, vendors' names are far from being standardized. And I mean, Thermo Fisher is referred to so many different ways. So we need to standardize that. And for that, I think I'm going to work a bit with CRARIP, because you've started doing some standardization in light microscopy. And in conclusion, so ACCS has dealt with various aspects of data management. It's enabled metadata collection, which is critical. And for that, it's actually sparked interest from various aspects. Sorry, it sparked interest from universities for their own operational purposes. So it was really interesting for us. Lesson learned, ACCS was a massive project, very distributed, very time-consuming in that aspect. As I said, having an e-research support is essential. The rollout of PG was essential, but you have to deal with the fact that the facility, the instrument scientist, you're changing their habits. You need to get them on board, and that is essential. And many, as I just said, many of those outcomes mean changing habits. That takes time, and you always have to justify or trying to convince them you're asking a change for the better. And that is many people I want to acknowledge as part of the ACCS. And we also interviewed many facilities in Australia and overseas about the challenges about big data EM. There's a report about that. It's in the link I gave earlier.